Hi, in this short tutorial, I will review question 3.2 and solve it analytically. Let's open up the slides. Okay, on the screen you see question number 3.2. So we have two independent events, G and H. G represents the event that the randomly taken student takes the math class, and H represents the event that the randomly taken student takes the science class. And probabilities of G and H are 50% and 30% respectively. And we have three questions to answer. We want to find out a probability that the randomly taken student takes G and H class at the same time. And this is denoted by G intersection H or G and H at the same time. This is question A. Question B asks that what is the probability that the randomly taken student takes either math class or the science class, and this is denoted by G union H, or in other words, either G or H. And finally, we have question C, which asks what's the probability that the randomly taken student takes math class conditional that the student takes science class, and this is denoted G conditional H. So H happens and we are looking for probability of G. So those are the three questions we would like to answer. Four possible outcomes in this experiment. So if I choose a student, that student either takes math class and or does not take math class. At the same time, that student might take a science class or might not take science class. So overall, we have four different rectangles. So the first rectangle is the student takes math class and takes science class. On the top of it, we have that student takes math class but not science class. On the right hand side of it, we have that student takes science class but not math class. And finally, the fourth quarter of this rectangle represents that student takes neither math, neither science class. So the first question asks, what's the probability that student takes both of those two classes? So then we are talking about the area, which is the lower rectangle, and the base is 50% and the height is 30%. So the area of that rectangle would be 15%. So 50% times 30%, which gives us 15%. Okay, so don't get confused with the calculation of percentages, because 50% translates as a 0.50, 30% translates as a 0.30. Product of those two numbers is 0.15, which is 15%. Okay, so that answers question 3.2a. Now let's look at the next question. So now we are talking about the probability the student takes either math class or the science class. So then we are so this event occurs if student takes either math class and science class, or takes math class but not science class, or takes math class or takes science class and no math class. So we are talking about three possible rectangles here. So how you solve this problem? So we need to sum up the areas of those three rectangles, or alternative way would be sum up the two rectangles, one vertical rectangle and the other one horizontal rectangle, and take out the intersection. That's what I do on line 1. So area of the vertical rectangle is 0.5, which is the probability that student takes math class. Area of the horizontal rectangle is the 0.30 that the student takes science class, and we twice counted the students who take both classes. So we take out once this intersection and we get 0.65, which is 65%. Okay, so alternative way to calculate this area of those three rectangles would be to take subtract 0.35 from 1, where 0.35 represents the area of the upper rectangle. Why? Because probability the student does not take math class is 50% and does not take science class, it's 0.70%. So product of those two is 35%. So the area of the white rectangle is 35%. If you take the 35% out of 1, you get the 65, which represents the area of those 3 rectangles, 2 blue and 1 red. So that's the probability the student takes either math or science class. Now let's look at question C, so which asks what's the probability that student takes math class conditional that the student takes science class. So one thing we need to note here is those two events are being independent basically means that knowing whether student takes a science class or not has no impact on the proportion. So we are basically asked if the student falls into 2 rectangles, yellow and blue one, what is the probability, what is the relative measure of the H area? So, and this relative measure would be the intersection, which is the yellow area, divided by the total area, which is yellow plus blue. Yellow plus blue is 30%, and the yellow is 50%. So if you divide 15% by 30%, you get 1/2 or 50%. So that's the conditional probability that student takes math class conditional, that we know that he takes science class. But again, if you notice here, this conditional probability equals unconditional probability that the student takes math class, which we know initially was 50%, but this is the good way to demonstrate it. So that basically concludes question 3.2, and thank you very much for your attention.